In this second Excel tutorial, we're going to use the data results table from your hydrogen lamp spectrum experiment to show how to create a plot with a trend line in Excel. So we'll open Excel. I want a blank workbook. Again, I'm going to zoom in a little bit so you can see my screen better. Now, the first thing we're going to do is to get the calibration curve for the spectroscope. When you do that portion, you'll be taking spectroscope readings, which will be in arbitrary units 0, 1, 2, 3, all the way up to about 12. And those will correspond to specific wavelengths of your helium calibration lamp, and those will be in nanometers. Now, whenever I make a plot in Excel, I want an XY plot. All of the information that should be on the x-axis will be in the first column, so column A, and all of the information for the y-axis will be in column B. So this is always the format that Excel will expect. The left-hand column is your x values, the right-hand column is the set of y values. Now, for this column, I want my spectroscope readings, so I'll type in that data label. And here will be the wavelengths of the helium lamp. So helium lamp wavelengths, and the units will be nanometers. Now you'll notice that the data labels are overlapping, which is not what I want. So one of the features that will be useful in Excel is to wrap the text, meaning the text doesn't extend out to the right, but instead wraps inside the particular grid where you entered it. So I'm going to highlight these two, and now I'm going to do a right click inside of that selection. I'll slide down in the menu that opens to Format Cells. It will default to the number selection, but I obviously want to change the alignment, so click on Alignment, and then slide down and check the Wrap Text button. Click OK. My columns are a little bit too narrow. I'm going to highlight both of them, slide to the edge, and change that width. Okay, so now I'm going to enter my first few values. I just enter the first couple. So 1.20, 1.72. And again, these are arbitrary numbers, so there's no units involved. These will be the wavelengths. These will actually be in your lab book, so you won't have to find these. You'll just look them up in your lab book. So again, I'll just type in the first couple. I have several more to go, so rather than have you watch that part, I'm going to stop the video. I'll type in the remainder and then. Okay, so I finished typing in the rest of my spectroscope readings and wavelengths. I've got 8 points in all. One thing you can see is that because some of my numbers ended in 0 in the spectroscope readings, not all of the numbers here have 2 decimal places. So I'm going to highlight all of those, come up here to Home, and increase the decimal places to 2. Now all of my helium lamp wavelengths are out to 1 decimal place, so those all look okay. At this point I'm ready to plot my data, so I will select all of my data, click in the upper left box, hold the mouse button, slide down to the bottom and release. I want to insert a graph, so I'll come up to the Insert button, slide over here to the Charts area. There's several choices. But in nearly all cases in chemistry, what you'll want is an XY plot or what's called a scatter plot. That's this little symbol here that just looks like a series of points inside of a graph. Now I'll click on the arrow that's next to that little icon. Now comes a menu which offers me several choices. I want just the points themselves, so I'll select this. And there is my generic plot created for me. Now I can click anywhere inside of that. While holding the mouse button, I can move the chart around, so I'll place it here. One thing is you'll notice that my X scale is longer than it needs to be, so I'm going to double click on one of the numbers, which will open a dialog out to the right, which allows me to change several options about that particular axis. But the most important thing I want to change is the boundaries, the minimum, the maximum. So I'll just change the minimum from 0 to 400. And then if I click outside of that, you'll see that my scale has changed, minimum of 400, maximum of 750. All of my data is visible, so I'm ready to go to my next step. So I'll go ahead and close that particular formatting box. The next thing I want to do is to add a series of chart elements, axis titles, and the trend line. So I'll click anywhere inside of the chart. That will highlight it, open up this chart tools choices in my menu. I'll click on design, all the way to the left to chart element. The first thing I want is one of my axis titles. The primary x-axis I click on, and I can see my choice here is just a generic title. So inside of that, I'll click and then select all of that and change it to my X value header, which is spectroscope readings. And now again, click inside the chart anywhere, design, add chart element, axis title, primary vertical. Click inside that box, select all of that, and now helium, lamp, wave, lengths, nanometers. Well, my chart is labeled at this point. The last thing I want to do is to add a trend line to my data. So design, add chart element. I'll slide all the way down to trend line, but without clicking on it, once I reach the trend line point, a box will open to the right. I want a polynomial fit for this particular experiment. That choice is not amongst those that's shown, so I need to slide all the way down to more trend line options and click on that. In the box that opens to the right, you will see that a linear fit is the default, but I want polynomial fit, so I'll select that. I want a polynomial of order 3, so I'm going to increase the order from 2 to 3. The last thing I want to make sure I have on my chart is the equation for that fit, as well as the R² value indicating goodness of fit. So I'll slide all the way to the bottom of that particular dialog box. Display equation on chart, I'll check that. Display R² value, I will check that. Okay, at this point my graph is complete. I can click inside that equation box, come to the edge, hold my mouse button down, move it wherever I want. You can see I've misspelled spectroscope, so I'm going to highlight that. Click inside, add the E, and there we go. My chart is completely formatted. This equation is the one that I'll need for my calibration in the next portion of the experiment. So that information is going to be very useful to you. The last thing I would need to do is then to save my chart. Come over here to Save As, and you can decide to put it in whatever directory you would like on your computer or in the cloud. So that's it for this particular video. We'll add more functionality to our Excel knowledge later in the semester as required.